Thank you. Welcome, everybody. Yes, I am wearing a hard hat. There is a reason for this. I'm inviting you to join me at the Dev Lounge downstairs. Come and see where we've trained a machine learning model for worksite safety. This machine learning model will detect if a person is wearing their hard hat or not and can be used to raise an alert. It's just one of the many uses of machine learning, and we're going to talk about a lot more uses today. So today we are going to look at a number of tools in the AWS cloud to help you with machine learning. Machine learning is becoming ubiquitous, and you're going to see a lot more of it over the next few years. Just this morning, as I was walking from my hotel, I met a lovely man from Wellington City Council, and we were talking about how Wellington Council is looking at how they can use machine learning to help, improve the lives for their citizens. We will be having some code on screen today. I don't want that to scare you, okay? The code is not there for you to learn. However, if you want the slides, you can get them afterwards and use that code. But it is more to illustrate how little code you need to achieve some goals. We'll be looking through a few use cases together. I'll be presenting you with a problem. I'd like you to consider how you might solve that problem, and then we'll look at how to solve it using the tools in the AWS cloud. There will be something for everybody. Non-technical folks will be introduced to the art of the possible. Developers will learn how they can use machine learning tools to enhance their applications. And even the most experienced machine learning practitioners will learn how tools in the AWS cloud can remove a lot of that undifferentiated heavy lifting. So as we talk today, I'd really like you to keep in the back of your mind, what sort of business problem do you have that machine learning can help you with? And then come and talk to us. So we see customers getting value with medical diagnostics, predictive maintenance of machinery, doing early damage assessments on images, perhaps looking for signs of damaged packages coming off the factory floor or in a postal facility, of course, recommendation engines and fraud detection. These are just some of the use cases. Please think about what machine learning can help you with, so you can talk to us and we can help you. So today we'll look at a bunch of tools in the Amazon machine learning stack. So we divide these typically into 3 layers. The top layer is what we call the application services. These are pre-trained machine learning models. You do not need to train these, you just interact with them via an API. We'll be looking at 3 of those. But there are some more there. So we'll be looking at image recognition, video recognition, we'll be looking at transcription, we'll be looking at comprehension of the written word. But if you want tools for text-to-speech, for obvious language translation, or for writing your own chatbots, there's tools there too. I'm just going to skip to the bottom layer. This is more, I guess, the DIY layer, but also the supporting layer that supports all the tools above it. We will look in the middle layer at a great tool. I love this tool. It's called SageMaker. This takes away a lot of the heavy lifting involved in machine learning. Machine learning is not easy, or certainly was not easy. SageMaker is there to make the process a lot easier for you to consume, and we will have a good look at that. So let's move on. I'm going to present you with a problem, and I'd like you to think about how you can solve this problem. Here's a photo of Andy Jassy. He's the CEO of Amazon Web Services. But this could be any person that you want to look for. Given that photo on the left, understand his face, and then if I give you a large collection of images, find every image that he is in. Now, traditionally, this is a difficult problem. I've run this through recognition, and I'm going to show you the code to do that. And recognition has come back, just for this image on the right, with a 98% confidence level that Andy is in that photo. And you can see he's on a bit of a different angle. So how much code does this take? Traditionally, a lot. This is how much it took me. Now again, I'm just going to highlight, this is Python code. You don't need to feel confronted like you need to learn this, but I want to highlight how little code there is. And if you want to build this yourselves, please scan, get the slide deck, and go ahead and build. Pretty much what I'm doing here is running one method called compare faces. I'm saying 75%, only return a value if you're more than 75% confident, and reading the response. So how could you use this? Perhaps you might be looking for missing persons, or perhaps you might have a camera wanting to only let known staff through a door. You could use it for intelligent image tagging of who is in photos, including celebrity recognition is built in. Recognition does so much more than just facial detection. You can do object and scene detection. It can automatically filter adult content. We have customers who need that. And it can also extract text from those images. But what about a more complicated use case? What about if it's not a still image, but a video? And I'm saying to you, don't just pull out videos that Andy Jassy is in, but tell me the timestamps where Andy Jassy is key in the frame of that video. So let's have a bit of a look at this video and see if recognition is correct, because recognition has told me that Andy Jassy is in frame between the 14-second mark and 18-second mark, the 20